Hey class, Absolute 5 here, and today we're going to talk about the third part of exponents, and the rule is going to be about the power of product rule. Power of product rule. So before I even explain what it is, let's start off with an example. So I've covered where we have one exponent being raised to an exponent that's being raised to another exponent. That was in the last video. So what happens if I have multiple things being raised to an exponent? Well, let's do exactly what this exponent is telling us to do. xy times xy times xy. Now, I already covered that you are not allowed to combine bases that are different at all. But since you are technically expanding this in a way where you just multiplying the x's with the x's and the y with the y's, so there's a 1 in the x here, 1 in the x, 1 in the x. So I'm allowed to what? Add up all these x's to get x to the third. But remember, you're still being multiplied by the y. So don't forget about the 1s for the y. So this becomes y to the third as well. So essentially, if we were to look back at this problem, you could put a little 1 here and a little 1 there for the x and the y. And you could kind of say that you're kind of distributing this 3 by multiplying the 3 into the 1 and multiplying the 3 into the other one for the x and for the y. So I get x to the third and y to the third respectively. So that's the concept of power of product rule, where you have multiple objects in the bracket and you're being raised to another power. So let's write in general what that would look like in terms of in mathematics. So in general, if n is a positive integer and a and b, yeah, that's a tongue twister, are real numbers, comma, then what you're saying is if I have two or more objects in my parentheses, and they're both being raised to a power of n, I'm allowed to just simply distribute the n to both the a and the b. Or let's say I had three objects. I had a, b, c to the n. It would be a to the n, b to the n, and c to the n. Okay? That's the rhythm. Now, let's do an example. So remember, I'm gonna repeat this twice. Every single thing that's in the parentheses, you have to distribute that exponent to that number, to that base, I should say. Let me repeat. Every single thing that's in the brackets, like this. For example, if I gave you 3x to the fifth, you have to apply that rule to every single thing that's in the base. Okay, so let's get that clear. Now, why do I say this? Because I say that so many times because I have so many students where they'll do this. They'll just say, oh, my answer is going to be 3x to the fifth. What are you forgetting? You're forgetting about the 3. The 3 is also being affected by the to the fifth power. So my answer to that would be wrong if you were to give me as an answer. If that was one of your answers, then that's a no. So to avoid that mistake, you have to put a little 1 on top of the 3 and a little 1 on top of the 5. So that now you have an exponent being raised to another exponent. Therefore, it will be 3 to the fifth times x to the fifth. So, and if I were actually to evaluate that, that would be, that's not 81. That's 243 x to the fifth. And some of you might say, how did you get that? That's a big number. Well, it's 3 times 3 times 3 times 3 times 3 3 times 3 is what? 9. 3 times 3 is 9. 9 times 9 is 81 times 3 will give you 243 as your answer. I know I made that look easy, but it takes practice for you to get into the rhythm again, okay? For those of you who haven't done mathematics for a very, very, very long time. So remember, this is called the power of product rule, where you're kind of distributing the n into each and every single exponent in the bracket, if that makes sense. Let's do another one. Let's say xy is being raised to the 7th power. So using that rule, we can, remember, put a little 1 there, a little 1 there. So this becomes x to the 7th and y to the 7th power. Very straightforward, I would say so myself. Let's do a little bit of a hard one. I want a challenging one for you guys to really, really sink your teeth into, really understand what's going on. 5x to the 2nd, y to the 3rd, and z to raised to the 2nd power. Now, when you first look at this problem, you're like, oh my God, this is a mess. What am I gonna do about this? So how do we do this? So we do what we do best. Let's put a 1 where you see no 1s there. So for example, you're gonna put a little 1 in front of the 5 so you don't forget about it, because again, students will probably put a 1 for the z, but they'll completely forget to do that for the actual number. Okay? So, knowing this, what you're going to do now is distribute the 2 by multiplying the 2 into the 1, multiplying the 2 into the 3, multiplying the 2 into the 2, and finally the 2 into the 1. So let's do it from left to right. 1 times 2 will be 2, so it'll be 5 to the 2nd. I have 2 times 2 is 4. Next is the y. 3 times 2 is 6. And finally, z to the 2nd, because 1 times 2 is 2. So that wasn't too bad so far. Let's do this one. Let's say I had something easier than that one. Or not even, let's just have something similar to that. Let's just say 4x, y, z to the 3rd, to the 6th, and to the 7th. And I'll put this as square, and this is to the 3rd as well. So, see, when I put a value already there, you can easily see what that is. Now, in this case here, in the last example, the answer is technically supposed to be 25x to the 4, y to the 6, and z to the 2nd. Now, granted, actually, let me change the value of that too, sorry. The reason why I'm doing that is because if I'm giving an exact answer in the last problem and I want to do the same thing for this one, 4 to the 5th is a very big number that I'm not sure I want to do on camera. So the first step is when it's just the 4 there, again, you're going to put a little 1 to indicate, okay, there's a 1 exponent that I need to multiply and distribute it by the power of product rule. Right, power of product rule. Sorry, just making sure I said it right. Then, again, you distribute the 3 into each and every exponent because you're multiplying them. So it's going to be 4 to the 3rd, x to the 9th, y to the 18th, and z to the 21st power. But after I multiply this out, I should get 64x to the 9th, y to the 18th, and z to the 21st power. So now I'm going to give you guys your homework. Sorry, but before I do that, so I hope that made sense for you guys, and then to always be aware of what you need to do, how to do it, and what's necessary. What are the steps necessary to do this type of problem? All right, so let's give you one problem this time. This is going to be 2p to the 4th q to the, not to the r, to the r, right? To the 2nd power r being raised to the third power. Leave your answers down in the comment section below. And that's the lesson for you guys. I hope you enjoyed it. Like, share, and subscribe to my channel. If you have any feedback, please leave them in the comments down below. Mash that bell button for more content, and I'll see you guys next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate.